Welcome to the Programming Electronics Academy podcast. Join us every other week as we explore how everyday people are creating extraordinary things in the world. Find us online at programmingelectronics.com.
Hello, this is Michael with Programming Electronics Academy. Thanks so much for joining me this week. We have got a really interesting show with Jelle Reith, and he's going to talk about a project called Compass. It's a wearable device that responds to direction. And it's a little difficult to describe, voice only, just, talking about it. But I think we do a pretty reasonable job in the show. I will say that it's like you're wearing a compass, and these flaps on your body, depending at which direction you're facing, different flaps will kind of lift and close. And so you get this tactile feel, this auditory feel, and it's just really, really rather interesting. And again, you'll hear all about it in the show. But we heard about this because it was actually featured on the Arduino blog in their maker videos. So it was pretty neat. Anyway, without further ado, let's go ahead and jump in. All right. Well, hey, everybody. Thanks for joining us. I'm here with Jelle Reith. Jelle, thanks for joining me.
Yeah, you're welcome.
And we're here to talk about a really interesting project that you've named Compass, that you've worked on. It's actually featured on the Arduino blog with Arduino makers, and it's really pretty sweet. It's visually very appealing, and I'm sure it's a wearable device. And as the name implies, I think I mentioned the name, it's called Compass. It's kind of like a wearable compass. So if you think about the app on your phone, most people have a compass app on their phone, or a lot of people do, I suppose. Imagine wearing that compass on your body and getting like a tactile indication of where direction is. So I guess there's a lot of interesting things to talk about this project, but I'm curious, how did you, before we start talking about the project, how did you even get into working with Arduino and electronics and programming and that type of stuff?
Well, that sort of started when I was quite young. My dad used to have a model train track, and I sort of took over when I was 5 years old, I guess. So then I started to work with electronics and get used to soldering and sort of making my own things. And then when I got into Artes high school, I started really working with Arduino as well. Before I just used basic motors and batteries to power my things, and then I started to also work with programming and sort of make the connection between stupid motors and sort of smart programming to basically make stuff.
That's cool. So kind of started with model trains with your father, and then following into school and that type of stuff.
Yeah. So my dad used to be an electrician, so he knows quite a lot about it. And my mom is actually, she was an artist. Now she has another job. And basically those two inputs shaped me into someone who knows electronics as well as sort of the art scene. So I combine basically those two things and make, for instance, the Compass wearable. But I did loads of other things as well.
Well, that's awesome. So what was the inspiration for this Compass project?
Well, actually, we got an assignment where we were asked to get into your phone and choose one app and make it a wearable.
That's
so
cool
I was looking.
assignment.
Yeah, it was really nice, and we couldn't download any new apps. We just had to use one that was installed on our phone at that particular moment. And I started looking through my apps, and I saw the Compass apps, which is quite a weird thing because you only use it when you're traveling. But at that point, you don't really want to look at your phone. So you basically want another sort of input on your body to basically point you to a direction. And then I started, making the initial sketches of this wearable and trying out electronics. So I was looking at a website called Cobberkant.at. And it's a sort of a wearable website where you can just learn to make basic things, and there was one example that basically was a wing that could flap, as in my wearable. And when I got home, I saw it at school, and I got home and I just made a thing and worked quite well. And then I made 10 because I thought, yeah, more is better. And so it was a very crude setup where I didn't even use an Arduino, but just a battery and some loose wires on the back of it, and I could just sort of skip the battery across the wires, and some would sort of flap open. And it was a really nice effect I got. And then I started making it smart with an Arduino and sort of control the patterns that it would create in the wearable. And that was quite amazing when I got the first thing working, where it was sort of making an animation across the first part of the wearable. It was sort of amazing to see this sort of wave of flaps opening up. And sort of that's how this project came across, where I just made one piece for over your shoulder, and later I made one that goes around your hip and one on your leg. Sort of stitch them together.
And so just, because everybody's listening right here, they're probably like trying to get their minds around what it looks like. And we'll make sure to link to the video, which is a really cool video on the Arduino website. But it's kind of like a partial vest in some regard, kind of like a partial vest maybe, and then there's kind of like a hip, kind of almost like a holster type area, and there's these pieces of fabric, and they're I guess not rectangular, but I don't know, trapezoidal.
It's more more diamond.
Yeah, kind of diamond shaped, and they flap up and down. And is it so? I guess I'm still trying to understand. After watching the video, I read the description. How exactly because it almost looks like wind is hitting the suit, and that's what's causing the flaps. But clearly, you've got some type of device on there that's pushing away each flap, and I'm curious how you do that.
So it's basically just an electric coil and a static magnet that are put over each other. So when you power one of the coils, they generate an electric field that pushes off a static neodymium magnet. So that basically when you apply voltage, they sort of flap open. That's basically it. It works sort of the same way speaker works with an electromagnet and a static magnet.
Oh, that's cool. So you just adjust the voltage, and that kind of adjusts the size of the field?
Yeah. Basically, it's always actually pumping 4 to 5 volts through the coils. So it's not really that I can adjust sort of the height of the flapping motion, but I can adjust the time the coil is basically powered, which then determines how far it will flap open.
Okay, I see. So you adjust that time domain, and that in turn affects. Okay, I see. That's cool. And so you have how many flaps are on? So how many of these coils are you controlling?
It's around 70 to 80. I'm not sure actually.
Wow, that's a lot.
Yeah, it was actually my first sketch consisted of only the piece over your shoulder. But when I made that one, I was so amazed by sort of the thing it could do that I decided to just make more. And it was actually, it's working with shift registers and some transistors to power the coils. And in this way, I can just infinitely stack more of these suits together, or these pieces. And you just have to adjust the code so it knows that there are more shifters present in the suit. So I made it in a way that it could just sort of infinitely go on with these pieces.
Okay, so it's expandable. Okay, and so you can basically individually address each magnet, or each coil. Okay.
Yeah.
Wow.
Yeah.
And you said, I believe in the description you said you're using I2C to do that.
That's for the sensor.
Okay.
That's the sensor is sending data over that protocol. But the coils are, it's just using shift registers.
Okay. So the what sensor are you using to? So I'm assuming some type of compass sensor, direction sensor.
It's a HMC 5883L.
And is it like a breakout board of that you're using, or okay?
Yeah. It's just the one you can buy from Adafruit.
Was it easy to implement, or?
Well, yes and no. Like the first I tested just getting data from the sensor. It was quite easy. But then I ran into the problem where the sensor was interfering with the magnets that are in the suit. So I get really weird readings. And there was sort of also when I would lay the sensor on one of the magnets, it would instantly sort of not work anymore because the sort of calibration would get off. So actually I had to replace the sensor a couple of times, and then at a point I realized that I should move the sensor over to the other shoulder where it was not really interfering with the magnets anymore. But like the sensor is quite easy to communicate with some libraries, but sort of the interference with the magnets in the suit was a bigger problem.
Wow, that's interesting. And so it's still not too far. I mean, it's still relatively close. It's probably within a foot or a foot and a half of the magnets, and it's operating fine now.
Yeah,
Okay.
it's okay.
That's cool. So when do things flap? How do you have it set up?
Yeah, basically the sensor is always just sensing the north, and then the Arduino asks the sensor where the north is, and you get a number relative, basically a number between 0 and 360. And that data is mapped over an array of sort of columns. So if you look at the suit, you see basically some vertical lines that sort of go from the from the shoulder piece to the hip piece to the leg piece. So that's sort of one axis of a two-dimensional array, and then all the horizontal flaps are like in another like array. It's hard to sort of explain.
No, I think I get that. So you've mapped the direction, the degrees to an array, and then each array is associated with a column on the suit.
Right.
Okay.
Yeah.
And so is it like 10 degrees for every column, or is it 20 degrees?
About. Yeah.
Okay.
It's not sort of it's not that every degree has a column or every 10 degrees. It's sort of one. For instance, your left side will have more rows because there you have a part of the hip piece and a part of the leg piece, and your right side basically only relies on the hip piece. So it's about at least 20 degrees, but sometimes it's less.
That's cool. And so basically, if I was facing north, the flaps on the front of me would be flapping, and then as I turn away, the flapping will rotate across my body to the north. So it's so cool looking, and I didn't get that like when I first watched the video. I must not have read the description close enough, but I'm watching, I'm trying to understand like, well, why are these flaps moving? It looks so cool. It looks so neat, but I'm like, how is that working? But now that you've explained it makes a lot more sense. So you got to wonder watching the video, what's it feel like? Can you feel it also? I mean, the audio in the video is great. So you can kind of hear that really neat, like clicking noise as those flaps go up and down. That's really kind of a neat audio, but do you get that haptic feeling as
you do? Yeah,
that's cool.
Yeah, you can feel the flaps. It was sort of not when I thought of the project, it was not really in sort of the feature package, but it turned out that you could actually feel it, and that was really nice because now you can also feel the flaps on your back as you're sort of facing south, basically. And actually there was a project that came from this project where we really made the coils so that you could really feel them. So it was a completely different thing, but there we actually used the H bridge to drive the coils, so then we could flap the flaps up and then sort of reverse the polarity so they would smash down on your skin and you would really feel the feedback there. But it's a different project, but it came from the same idea basically.
That's cool. So what's it like? Do you, after wearing it for a little bit, do you get a sense, like, is your brain doing something, do you think, to say like, okay, I'm starting to associate these sensations with a direction, or is it just, I'm curious if there's any transition there mentally.
Yeah, that's basically what happens. So you have to wear it for, I guess, 4 or 5 days. But at some point, your body will start to adjust and start to recognize that the flaps are something have something to do with your position. There was another project where someone made a belt with vibrating motors, and they would wear it for a couple of weeks, and then they would really merge into a new sense that you get from wearing the device.
Right. Yeah. I mean, I guess like at its basic point, it's just more, sensory inputs and your brain is,
Yeah.
adjusting or that's really interesting. So do you have plans for the future for this? Like you kind of talked about how you were spinning it off with another idea there, but anything else you're going to move with this, or do you think you're going to bench it for a while or what?
I'm not sure. Not for 1 year. I'm not gonna work on it more because I also next year I have to graduate as well. So I don't think I have time. But later I want to sort of continue with this idea of having flaps on your body, and maybe make some PCBs as well, because so the electronic part was quite a little bit of messy, where I had to solder quite a lot of things, and it's a really easy thing with the shifters and some transistors that you can just make a breakout basically for Arduino, where you have multiple outputs for coils. So I think I will make some PCBs for this, and maybe make some more of these wearables with flaps. That's quite interesting. If you look at wearable design, they usually end up in a mapping from some sensor to a light or vibrating motor, and this thing, like the flaps have sound and they have haptic feedback as well, so they're just pleasant to look at. So you have basically three things going on for them. Which for me is quite amazing.
Yeah, in fact, I would say that, I mean, like, obviously the compass part is cool. I love the fact that it adjusts and, the flaps move based on position or direction, I suppose. But just there is a very aesthetic appeal to how the flap goes up and down, because, and to people listening, so the flap, it's kind of like a piece of harder fabric, I guess, or like stiffer plastic maybe. And so, or material, cloth, I suppose. And the top of the flap is gray, but the underside is white. And so it flaps up and you see just this white kind of image, or I don't know, this white, you see the profile of the flap, I suppose is what I'm trying to say. And so it's not just like, a homogeneous thing. It's the color or the differences in shades are actually quite interesting. So I could almost see like, I mean, that would be an interesting thing, just to have like a whole wall of those flaps and then kind of do interesting things with that, kind of like, I don't know, painting pictures, moving pictures with those flaps. It would just be rather interesting. But I'm sure those are all things you've thought about.
It's basically just pixel, so it can be white or black. Of course, when it flaps open, it gets white. So yeah, of course, if you have a whole wall of these things, you can probably even play a video on it.
Yeah, absolutely. Which would be pretty neat, I must say. So with the, you were talking about when you're able to pull it up and then push it back down, like reverse the polarity. Can you control then like the open time essentially? You're not relying on gravity anymore to pull it down. You can kind of whip it down faster.
Yeah, you can. You have basically more control over the coils, and so as well. What we were also testing is when you have the coil on your skin and you don't flap it open, but basically just retract it. While it's not even in the air, you also feel it, and so it moves like a little bit. But you don't even have to flap it open and then smash it back down. You can also just pull it closer to the fabric, and then you will get this haptic feedback as well. But with sort of an H bridge, you can basically do more than what I did in the compass wearable.
And the it shows here that you used you mentioned at least in the on the Arduino page that you used a 3D printer for it. What was how did that come into play?
Yeah, that was basically just for the electronics enclosure. So under your right shoulder, there's a piece with electronics, the Arduino, and some the battery and the sensor. And then in every piece, there's also a board with the shifters and the transistors. And those boards basically have a small case around them for protection. Yeah, and I just 3D printed the cases so they would fit nicely. And also I made some holes where I could sew them to the fabric as well.
And is it your 3D printer? Or is it just available to you where you go to school?
Yeah, it's at my school. We have a workshop where we have a lot of tools which we can use, as well as a 3D printer. Actually, we have 4, I guess. Yeah, but it's just a tool like everything else.
All right, that's cool. Sweet. Well, hey, Jelle, I really appreciate you taking the time to talk, and I'm sure people will have found this project very interesting. Again, I'll make sure to link to the page on the Arduino website. Is there anywhere else you'd like me to send people if they want to check out the project?
Yeah, you can just go to my website.
Okay.
And there are more projects than just the compass thing.
Okay.
I recently just added some new projects because I just finished this year. Yeah, so go check it out.
Cool. Well, you want to tell us about some of those projects just real quick, just a quick overview of some of the stuff you're working on to kind of whet our appetite for checking it out?
Yeah, sure. Yeah, there's one project, which I'm going to actually finish next week, I hope, where I build a paintball gun, and it's controlled by machine learning. So there's an installation where there's basically a gun that's controlled through 2-stepper motor, so you can have a XY position system. And then there's a target, and the gun basically shoots a paintball at the target, and when it hits, it gets positive feedback and retrains an algorithm. So over time, you see this algorithm growing and sort of adjusting to the space and to the camera feed that gets pumped into the algorithm. So it's quite a new project.
Cool. Well, hey, so if somebody was out there and they wanted to like get into electronics, Arduino, any recommendations for them? Any thoughts on any wise words to kind of get them on their way?
Yeah, well, I think you should definitely think of every part as a Lego block. Also, not only electronics, but everything can be an output and an input. And as you realize that sort of an LED can also be set up as an input, you can really start to stitch up electronics and also motors and kinetic things. And yeah, just basically think of everything as a building block for your project. That would be.
That's awesome. Cool. Hey, well, Jelle, thanks a ton. I appreciate it.
Yeah, no problem.
Well, I hope you enjoyed that talk as much as I did. We'll make sure to link to the video so you can check out how this thing actually works and visualize it. It's really quite neat, and it just leaves me with a bunch of ideas of how neat that would be to kind of implement that same flap lifting idea in different ways. So thanks a ton for joining us this week. If you haven't, you're welcome to subscribe to our show on iTunes, your favorite podcast feeder. And also, if you could take the time to rate the show in iTunes, that'd be much appreciated. And I just hope you have a fantastic week, rest of your day or whatever, and we'll see you next time. Bye.
This show is produced by Programming Electronics Academy, an online technology education company. We exist to help you create the technology you want in your life. If you are interested in learning more about Arduino, we welcome you to sign up for our free Arduino Crash Course, a 12-part video series with accompanying written lessons designed to teach the basics of programming Arduino. To register for the course, simply text your email address to 440-701-5311, or you can visit programmingelectronics.com and sign up there.